Hi everybody, I'm the greatest living inventor, and today we are doing my invention, space junk decelerator. So I'll write it down. Yeah, okay. Space junk maybe I'll change a marker because this one is tired. Thank you. And space junk decelerator. Okay, so I'm just taking off my jacket. By the way, this is my favorite shirt, t-shirt. Can you see what's written? Borders. I've never seen one, but I've heard they exist in the mind of some people. Okay, this is by the person who crossed the ocean with the raft, like the ancient people. I don't remember the details, but it's from Norway. He's Norwegian, and so in case it gets ruined in the washing machine, so I just wanted to immortalize this shirt. Okay, so slowing down space debris. Okay, we are going back to space junk decelerator. What does it mean? Slowing down space debris by regular ice, water ice, or by dry ice, CO2, and concentrating the ice in the projected projectile path, in the projected, what we think will be projectile path, where it will fly, without touching the ice by optical / electrostatic / microwave levitation. Okay, levitation. Okay, this idea has this idea is made of two halves. One, the first half, slowing down space debris by regular ice, water ice, or by dry ice, CO2. It turns out that, unbeknownst to me, this first half has partly already been invented by aerospace engineer Jim Holopeter. Okay, the part with the water ice. Jim Holopeter. Okay, but I didn't know about it, so I'm giving you the link in the website treehugger.com. Clean technology, clearing space junk from Earth's orbit by launching water at it. So I will put it in the video description. Okay, and another link, nbcnews.com, blah blah blah, technology and science agency looks ideas, clean space junk. Okay, and I'll give you the exact link. Here is the short description from Google Books. Space safety is no accident. The seventh IAASS conference 1.4.11 ballistic orbital removal system. Okay, he calls this the same thing, not exactly the same thing, but the first half similar to mine, ballistic orbital removal system. Ballistic orbital removal system. Okay, and I'll give you the exact link in the description. It's in Google Books. Space safety is no accident. The 7th IAASS conference, and it's in chapter 1.4.11 ballistic orbital removal system. So I'm reading to you, quoting, according to James Holopeter of GIT satellite, rockets filled with water could be shot into space. After releasing their payloads in orbit, it would create a field of crystallized water that would be penetrated by orbiting junk, causing it to slow down and fall out of orbit. Okay, now the second half of my idea, concentrating the ice in the projected projectile path without touching the ice by optical / electrostatic / microwave levitation. This second half has never been invented before, and it's necessary for the whole thing to work, so I can call it my invention. Okay, so philosophical background. How did I get this idea? Okay, I'm sorry, I'm a little rushing through things. It's almost 8 minutes, and we have 8 pages. Okay, so first of all the other solutions are based on a childish concept of hunting the pieces of junk. Nets, harpoons, shooting it with laser, catching it with a sticky robot. Okay, wikipedia.org, space debris, external removal. Okay, so you can see in Wikipedia. Space debris, external removal. So all of them are like childish ideas that don't work. These are not practical because the junk moves 7 times faster than a bullet, so it has a huge momentum. Good luck catching it with something hard in front of it. As for the method of chasing it from behind, it needs fuel expensive and time critical maneuvering because it's already at this great speed. So we need to think of something soft that is all over, the place. The spaceships will be able to fly through this soft thing by behaving unlike the junk. So the spaceships will fly slowly. The junk flies really fast. The characteristic feature of space junk is its speed. Without this speed, the junk could not maintain its course in its orbit. So the spaceship will need to go slowly, like in this sci-fi series, The Expanse. Okay, so The Expanse. Sorry, The Expanse with A. So, like in this sci-fi science fiction series, The Expanse. If you go into a room too fast, kid, the room will eat you. The room will eat you. This is like a sentence that one of the characters say. Somehow, Holden, the character that character tells him that, somehow Holden realizes that this means Alex needs to slow down and steer the ship into the ring. Okay, so I'm giving you the link if you want. It's in Gizmodo, IO9. The Expanse just delivered its most unbelievably tense something. I'll give you the link, the exact link in the description. So, what do we have that can give this effect of go fast equals stop, go slowly equals pass? So, the answer is non-Newtonian fluid. So I'm erasing this. Okay, so non-Newtonian fluid. Okay, so we've talked about non-Newtonian fluid in another invention of mine. So I'm just mentioning it, not really explaining everything. Like in this video, BRAINIAC, Science Abuse, John Tickle works on Custard by brainiacstore. Okay, so I'm giving you the name of the video, but we've talked about it really in detail in another invention. So I'm not going into the details. John Tickle. Works on Custard. This is like he has a pool, a small pool of some thick liquid like water with starch, and okay, this is like water with starch, and he walks on this liquid like Jesus walked on the water. So in case he walks fast enough, the surface of the water, it's not water, it's this special non-Newtonian fluid. It's not water because water are Newtonian fluid, and this is non-Newtonian fluid. So it behaves differently. It behaves like a solid if you pass it fast enough. If you go through it fast enough, give it a punch or a step, quick step, like running on it, then it can hold you because it acts like solid. Okay, the particles don't have time to move. but we've talked about it. I'm not going into details. So this is by BRAINIAC. Okay, I'll give you the exact link in the description. Sorry, brainiacstore. brainiacstore. Okay, so moving forward. However, the more I thought about it, the more I realized that with non-Newtonian fluid, the point is that when the collision happens, fast, the little particles don't have time to escape. But in our case, with the space debris flying 7 times faster than a bullet, nothing has time to escape anyway. So a regular fluid like water is good enough. So I'm still explaining the philosophy how we got to this idea. So how I got to the idea. So next I wanted to know how water behaves in space. There are many videos of playing with floating water bulbs in the International Space Station, IAASS, on YouTube. But these are not helpful at all because of the air pressure inside the ISS. So the water remains a liquid like on Earth. So then I found this nice article in Forbes that explains that it turns into a cloud of tiny ice crystals. Water in space, does it freeze or boil? Okay, so it's an article in Forbes. Water in space. I know it's not where you expect to find something scientific, but it's there. In space. Does it freeze or boil? Okay, really good article. Okay, by Forbes. And I'll give you the exact link in the description. So it's like that. So the simple strategy would be to throw the water in front of the piece of junk and to make an extended cloud through which the object will have to fly. The cloud of crystals slow down the object. Okay, so we have the object like some part of a satellite that doesn't work, and we have the cloud. And let's make the cloud in blue because it's water. Okay, and actually in the cloud there are ice crystals. Okay, so the naive idea would be that the cloud will stop it. So the simple strategy would be to throw the water in front of the piece of junk where it's going to come, and to make an extended cloud through which the object will have to fly. The cloud of crystals slow down the object. The problem is that the next time it comes around, the object moved quite a bit. Okay, so next time the object, imagine that below us there is Earth, and this is orbiting the Earth and orbiting the Earth again, and now it's slower, so it's orbiting lower, because that's just how the physics work. It needs a certain velocity to fly in each orbit. So it flies. If it's slower, it starts to fall down lower. Okay, so now it's here. So it's not going through the cloud anymore. Okay? The problem is that the next time it comes around, okay, rotating around, orbiting around the Earth, the object will not, the object moved quite a bit, exactly below, exactly because we slowed him down. It will not fall to Earth, it will just stabilize on a lower area because it's still fast. So the simple strategy, the one suggested by Jim Holopeter that we talked about, is not good enough. Okay, this will not work. How do we slow the object more? One, we can use more water in a naive way. Imagine a huge spherical cloud that just goes to waste. Okay, I'm not going to paint it, but like if there is a lot of cloud here, this is not efficient. We need a lot and lots of water. Okay, second, we can use a stronger material like dry ice, CO2. We talked a lot about CO2 when it freezes. It's called dry ice. And in my previous inventions, okay, this is frozen CO2. And I'm not going to repeat it. We talked a lot about it in previous inventions. So I watched a few videos on YouTube, and it can stop a bullet of Browning .50 caliber machine gun. Okay, so if you shoot it with a machine gun, it can stop this can stop the bullet, a block of dry ice. You can see in Wikipedia, and I will give you the link in the description, .50 underscore BMG, okay, Browning machine gun. And also see this silly video, dry ice versus the VS versus the 50, mind blown, exclamation mark, exclamation mark, exclamation mark, by DemolitionRanch. And I will give you the link in the description. So, they are shooting a block of ice, dry ice. Sorry, I'll just drink something. Sorry. Of course, these are solid blocks, and we use a cloud, but we use more length, and we just need to slow it down. Considerably. Sorry. So instead of water ice, we can use CO2 dry ice. This solution is good for what we need. The only drawback is that I don't know how it will affect the greenhouse effect. Okay, so it's problematic. As you know, we have a heat blanket around Earth that traps the heat inside, which is CO2. So dry ice is CO2. So on the one hand, we can get rid of CO2 that we dump in our atmosphere, that we dump in our atmosphere anyway, which is very harmful here on Earth, and throw it into space and achieve something good with it. On the other hand, I don't know how the CO2 will behave. Will it be like a greenhouse inside the greenhouse? So since we don't understand this perfectly, then this is too risky, not good. Okay, 3, like we had, how do we slow the object more than Jim's idea? So we had 1, the naive way, more water. 2, use dry ice, but we've seen that it's not good. It's dangerous, that it will make a greenhouse effect within a greenhouse effect. 3, we can use more water in a non-naive way. So not just put a bigger cloud, but do it more focused. So 3, we can use more water in a non-naive way. Imagine a long tunnel without walls, filled with cloud, and the tunnel's path predicts the path of the object. This is effective. Okay, so instead of just a cloud, we have like a tunnel, and in the tunnel we have the same stuff as before. Okay, so we are just changing the shape. Tunnel. Okay, and this is much more effective. So this is the solution that we will choose. For a fourth example, this was 3. Now 4, we can use a short tunnel or cloud and move it to meet the object the next time it comes around again and again. Okay, so we can move, if we had a short tunnel, not a long tunnel, a short tunnel, we can move it to here. We can move it to here, like follow the object that is orbiting around Earth, the junk, the debris. Okay, so we can use a short tunnel or cloud and move it to meet the object next time it comes around again and again to here. This is much cheaper than flying after the object. In order to intercept the object, we just move toward Earth the difference between the old radius of the object and the new radius of the object. This is effective, but less than 3. Okay, 3 was the long tunnel. Okay, of course, if we are very optimistic, we can combine 3 and 4, make long tunnel and even complete circle tunnel around Earth that shrinks again and again following the current radius of the object. Okay, if the object is this far from the center of the Earth, or this far, or this far. But I think this is the same kind of childish optimism that our hunting friends relied on. So from now on I will focus only on method 3. Okay, the tunnel. Okay, how do you catch a cloud and pin it down? Maria from The Sound of Music. Okay, if you haven't seen it, you should see it. It's one of the best musicals ever. Okay, we need to shape the cloud tunnel in space. We cannot build a box or an actual tunnel around the cloud. Okay, we cannot put the cloud inside the box, because that would itself become junk in space. So how do we keep the cloud in place without touching it? So I'm just erasing and giving us some kind of title. Okay, so I'm giving us the title of from the sounds of the sound of music. How do you catch a cloud and pin it down? How do you catch a cloud and pin it down? And this is Maria from The Sound of Music. The sound of music. Okay, so we need to shape the cloud tunnel in space. Okay, so we have, I'm just painting so we have something to talk about. No, it's 6, sorry. Okay. So this is not important that it will be 6, but inside each one it's important that it will be 6. This is the structure of water, of ice. Okay, so we need the shape of the, we need to shape, to give shape to the cloud tunnel in space. Okay, this is in space. We cannot build a box or an actual tunnel around the box, because that would itself become junk in space. So how do we keep the cloud in place without touching it? Okay, we don't want it to disperse, but we cannot put it inside something. We have the same problem as someone trying to hold something up in the air without actually touching it. This is called levitation. Levitation. Okay, so we have the problem of levitation. Like someone trying to hold something up in the air without touching it. There are methods of levitation that rely on air, like for example sound waves. These are not good for our purposes because space doesn't have air, so the sound wave cannot travel in space. But I just bring this video because it shows nicely what levitation is. We will use other methods of levitation that will give us the same result. So a video I'm putting in the description, the link. I built an acoustic levitator making liquid float on air by physics girl. Okay, so I'll give you the link. So I searched in this book the airborne microparticle, its physics, chemistry, optics, and transport phenomena by Professor E. James Davis, Professor Dr. Gustav Schweiger, Springer Verlag, 2002. And I found out about this article, which is excellent. Ernst Helmut Brandt, 1989. Sorry. Hello? היי. כן. כן. תיתה קצר, כי אני בהרצאה. הנעליים בסדר? כן. אוקיי, אז ביי. Okay, sorry. So anyway, I found a good article that's by Ernst Helmut Brandt, and the name of from 1989, and the name of the article, the good article, levitation. Okay, levitation in physics. Okay, it's from Science. Two, 4, 3. 349 hyphen 355. Okay, so it describes aerodynamic levitation, acoustic levitation, optical levitation, electric levitation, magnetic levitation, radio frequency levitation, and superconducting levitation. Okay, I think we should use the fact that water molecules have dipole, so they have a plus side and a minus side. Okay, water molecules okay, this is the oxygen, O, and this is the hydrogen, this one and this one. So I don't remember which is which, but let's say this is the minus side and this is the plus side. Okay, something like this. I think, don't get me wrong, maybe I'm wrong, but this is the minus and this is the plus. But anyway, maybe it's in reverse, but they have a minus and a plus. Okay, so Okay, I think we should use the fact that water molecules have dipole. This is called dipole, the minus and the plus. It's like a small like magnet, not magnet but electric charge. I think we should use the fact that water molecules have dipole, so they have a plus side and a minus side, so maybe we can move them in space inside an electric field. Also, another very interesting thing we can do is pass electricity through water. This can help them bridge over to some extent, even overcome gravity. Okay, bridge, water bridge. There is a video on YouTube, really nice, how to defy gravity with water, the water bridge experiment by plasma channel. How to defy gravity with water the water bridge experiment. By plasma channel. So it's with the S, plasma. Channel. Okay, so you can see it in YouTube. I will give you the link in the description. You should see it. They put two glasses and the link between them using they put electric charge, like one is a plus, another is minus, and the current makes the water bridge. Okay, so you should see it. Water bridge. Okay, and it even resists a little the gravity. Okay. So in space, it's easier for the electric current to form an arc from one piece of water to the other, like a water bridge. It will be like the lightning passes through air, but through vacuum. I hope it will have the same connecting together effect that we see in the video. So we can, if we electrify the water, I think it will be like they will arrange in a line. If we put a plus here charge and a minus here, they will conduct. Okay, like they do here. And in Google Books, I also found this article. We are already almost 45 minutes into the invention, so I'm not writing everything. I will write everything in the description, in the video's description. So in Google Books, I also found this article, NASA Tech Briefs, September 1991, page 61. Microwave levitation of small object. microwave levitation of small objects. So this is by NASA Tech Briefs, September 1991, page 61, microwave levitation of small objects. I'll give you the link in the description. So using such methods, we can trap the water like in a quadruple ion trap. Okay, quadruple ion trap. You can see in Wikipedia what it means, and also you can see this in the nice video Homemade Paul Trap by Nick Moore. I'm erasing this. Homemade Paul Trap by Nick Moore. Okay. So I'll give you the link to the YouTube video. Okay, one moment please. Sorry. Please note, we are not controlling the object. Sorry. We are not controlling the object, space junk, with these gentle effects of no hands levitation. Instead, we are controlling the water cloud and give it the optimal shape of the path of the object. The object comes from here, for example, so we give it the exact path that we need through all these techniques of no hands levitation. We control the cloud's shape, and give it the optimal shape of the path of the object. Then we leave the water floating there, and after a few seconds the object, the space junk, hits the water. I'm thinking of this controlling of the cloud like the superconducting magnets that we use in particle accelerators like CERN, to bend the particle beams without touching. Okay, we make a circle in the border between France and Switzerland. Okay. By the way, the big money in superconducting magnets is keeping them cool. So since space is very cold, at least where and when the Earth shades us from the sun, when we are in the shade of the sun, then maybe we can build superconducting magnets. So that's another technique that we can make. So we can make a loop of wire, like a collar around the path. Okay, so I'll erase a little because it got crowded, all the whiteboard. Okay, so we are making a coil. Let's make it in light brown. Okay, this is a collar. Around the cloud, around the tunnel. So we are making a loop of wire like a collar around the path and move it along the cloud to shape it. We move this along the cloud with the electrical current that we run through the loop of wire. Okay? Loop of wire with current, with electric current. Okay, there is electric current running through the collar. And then before the object comes flying, before the object comes flying by, we turn off the current through the loop of wire and take the loop of wire away so that it doesn't get ruined by the object. Another thing we can use is transmitting the microwave energy from drones that are located around the cloud, like the wire, but more loose at some distance so the drones will not be damaged. Okay, so another option is to make a drone. Of course, it's a solar or like a nuclear or some type of energy, and the drone makes microwave radiation, like transmitting microwave energy, and it's like pushes the water to where we need it. Okay, this is microwave. Drone. The microwave that we hit our supper with is also pushing the molecules of water, but there it pushes them and leaves them, like they just want to. We just want to make it vibrate to get things hot. But here we can actually push water. Okay. So and the drones, before the object comes, they move away. Or these ones don't even have to be that close, but the ones that operate the collar, the drones, this is also by drones that operate the collar. I don't know how to draw the drones. Okay, like robots that maintain this and then move away. Sorry. Sorry. Okay. So, okay, we are in 55 minutes almost, so let's rush things. We move them not to get damaged before the object comes, like a minute before or a few moments before. We can slide the collar along the cloud, and so we maintain the shape of the cloud tunnel. To form the shape of the collar, we can, to make this, we can have the wire rolled up inside the drone, like the electric cable of the vacuum cleaner is rolled up with a spring, and you can pull it out from the vacuum cleaner manually, and once you are finished with the vacuum cleaner, you press a button and the spring rolls it back inside. So the two wires will be pulled manually by another drone in this side. Okay. Sorry. So the two wires will be pulled manually by another drone, like the vacuum cleaner. And then the drones will push each other gently away from each other. And this will give us two parallel wires. Okay, so we have two parallel wires. In order to spread the wires away from each other, we can pass electricity through them, like in this nice video, MIT physics demo, forces on current carrying wire by MIT Tech TV. Okay, so I'm not writing the name because we are really need to hurry, but I'll give you in the description the link. So this, if you put the current, then it spreads. Similar charges repel, like plus and plus repel, minus and minus repel. Okay, the second drone then attaches a very short wire just to shortcut. Okay, to connect this. We have two wires, and to connect this, to close the circuit, just to shortcut the two wire ends that he holds, and then the first drone runs electricity through the whole ring. In order for the ring not to collapse back, we can help with two more drones. Okay, like one is pushing from your side, the other from the side of the inside the whiteboard. So we have four drones. Like if we look from the side, it's like a square. In order for the ring not to collapse back, we can help with two more drones that will just hold the middle sections open apart. How do we get the water up to space, and how do we get the water down to Earth? Okay, so I'm not drawing, I'm just telling you. I think we should be lifting the water to space without the use of rockets, because we can use a cheaper method and we don't care how much G-force the water endures, unlike astronauts. Okay, if astronauts, we cannot shoot them in a mass driver that we talked about, but a packet of ice we can. So Wikipedia, non-rocket space launch. I think we should make ice blocks, freeze the water, shaped like big bullets, and shoot them to space with a solar-powered electromagnetic catapult. Okay, Wikipedia mass driver. We talked a lot about mass driver in another invention. Okay, in space, the ice mortar shell, okay, the bullet, will disintegrate because it turns to cloud, and if not, we can make it punctured from advanced, like frozen, but with like Swiss cheese, if it's not disintegrating by itself. So we can prepare it so that it doesn't disintegrate when the sun hits it. Okay, heat in terms of temperature. It doesn't heat the sun, it just, the rays of the sun gives it a hot temperature. Okay, but this, so in space the ice mortar shell will disintegrate because it turns to cloud, but this cloud keeps going because it has the same inertia forward and nothing stops it. As for how fast we need to shoot the ice bullet, we can calibrate it after a few failed attempts. The material is seawater, okay, ocean water, and with the rising seawater we have plenty of it. In order to stop the cloud at the end of the journey, when it's relatively slow, we direct the levitation technology in the opposite direction of the bullet's flight until the bullet stops. So we use the same thing to stop the bullet. Okay, after we have something there. Okay, the first one should be calibrated more exactly, but the next ones, once we had drones and some water, we can move more water and stop it using the same tool. Okay. On the way back to Earth, the nice thing about this solution is that the water just falls back to Earth like clouds and rain. Okay, so this was my invention. So I hope it was clear, and I'll see you in my next invention. So thank you very much. Goodbye. Thank you.